All right, let's go ahead and get started, please. I think you all have had a chance to sign in already, so I'll skip ahead to the next slide. All right, so today our agenda is covering REST, which many of you have already know. Those get post commands for communicating with a database versus WebSocket APIs. That's something new we'll be talking about today. Today we're building, I think, a video game demo, and then Abby's going to lead the demo later on. So before we get to the demo part, that's going to be at the end of this presentation. If you guys don't have Git and Node installed already, go ahead and download those. And then there's a GitHub repository that you need to clone. So this is also in the demo document that we've posted on Discord. So in the meeting resources channel, there's a demo document that has the repository you need to clone. And then the following two steps are just to run npm install and then node index.js. And again, if you didn't get a chance to read the commands on the slide, just check the document in the Discord. All right, so what are APIs? API stands for Application Program Interface. And APIs kind of connect your app with a server on the back end so that you can request and post data to a database. So how does that compare to WebSocket, REST APIs versus WebSocket APIs, right? So there's a 7-layer structure that you'll learn in networking. Have any of you taken networking, computer networking? All right, so you'll learn when you get to networking that there's 7 layers. There's a physical data network transport session. I think layer 6 is missing here, and then application layer. And both of these function on the application and the transport layer. So REST APIs that you see on the right side of the screen are stateless. And like I said before, they use a request response structure. So anytime the client side requests data, they'll send the command to the server. And then the server will respond, and then the client will have that data. On the other hand, you have WebSocket APIs. Those are persistent. That means that anytime there's an update to the data, anytime the server wants to send data, it'll send it straight to the client without the client having to request and then receive a response. It also works bi-directionally. That means that the client and server are kind of equal. So take like a video game, for example, right? There's no specific like core player who serves as a server and then the other players are clients. They're all receiving and sending information to each other. So sockets versus web sockets. So sockets are more low level. They allow for more control. They're more general purpose, and they allow for more details to be handled. Whereas web sockets are more high level. They're more specific to the web, and they're easier to use. Let me see if I missed anything. Yeah, so WebSockets automatically handle connection management and allow for message-based communication, which eliminates the need for developers to manage low-level details. So the goal of today's workshop is to use WebSocket APIs, which are persistent bidirectional and allow for bidirectional communication like you see in this little diagram over here. So all 3 users are communicating with each other. It doesn't require any user to request and then constantly wait for a response in requests asynchronously. So why not just use REST, right? Like we already discussed a couple times, REST requires a request and response functionality, which doesn't allow for real-time communication, which is the point of today's workshop. This allows for polling for updates, and then there's also synchronization challenges. So REST APIs usually require asynchronous functions to be run, which kind of slows down the process, especially when you're dealing with something like video games. So you could use REST for slower games like chess, right? Chess is turn-based, which means that every time, say the white player makes a move, then black player would just request and then respond. And then you can function on a request response functionality there. However, this doesn't work if you're doing like say a first-person shooter game or any multiplayer game that requires like real-time communication. So not to get too repetitive, but WebSockets are just ideal in the scenario where you require real-time communication with the server. So the high-level architecture of our game has three main steps. The initial handshake uses REST. When a client or a user accesses the game in a web browser, the browser is going to send out an HTTP GET request to the server. The server responds with the HTML, JavaScript, and other assets needed to load the game's client-side interface. And then the socket.io library on the client side will also initiate a WebSocket connection attempt to the server. The next step is to establish the connection. So when the WebSocket connection is established, the initial handshake is complete. Then the server fires the connection event, which you can listen to on the server side. So this event provides a socket object that represents the connection to the client. And then that creates event listeners. The final step is the seamless communication, right? So the client and the server are sending data to each other using socket.emit. So that's a function similar to how there's .post, .get in a REST API structure. Socket.io uses a function called socket.emit, which we'll cover a bit later on. So the initial handshake is step one. So the client just says, can I join your game, which is the get functionality. The server says, yes, take this JS file, which is the response. Next step is that they establish the connection with the WebSocket API. So the WebSocket responds by just saying connected, and now both the client and server are connected to the same socket. Finally, the seamless communication step is when all clients and all servers are able to receive updates in real time. So that way, anytime there's a change to the game state from one user, that's reflected on all users. Fine. All right, so time to get into the demo. I think Avi has to share screen. So let's give that a minute. Before we get to the code, any questions so far? Yep, there. Yeah. Make sure to share your screen to the Zoom.
But you'd still be recording, right?
Yeah.
Okay.
So HDMI is connected, right?
Maybe I need to push it in. Okay. No. All right, there we
Is your screen being shared?
go. Yeah. Can you see it?
Yeah. I think it looks good. Just to make sure, Andrew, you can see the screen, right? Just let me know. Yeah.
Okay.
Thank you.
I'm actually gonna sort of first show you what it's gonna look like, so then you have a feel for what exactly we need to get done before we go ahead. So I'm gonna sort of log in with this username Bean. Once I do that, I'm in this movement game, right? So you can sort of move around with the arrow keys. You can't see my arrow keys, but I am pressing them and moving in some sort of random areas. And then if I open another instance of this, you see the other Bean up here, right? And then you also see me. So I'm moving around, and Bean is still in the position where he is over there. And if we do a bit of a split screen here, so if we do this, you can see that Bean is moving on both screens at the same time. So that's what the real-time connectivity is over here. Whereas if you had a REST API, like this would take a couple of seconds to orient itself, and you'd also sort of have to reload everything to make sure that like it's all caught up to each other. versus when you do it on sockets, you're basically creating a bunch of events that connect to each other from the front end to the back end. And I'll dig into that in just 1 second. But the basic ideas that we need here is an event for when a user logs into this page. So when they log into this page, you need to get their name, so their name shows up over here. I'm just gonna do that localhost, right? Now you have a blue guy and he's moving around. Cool, right? So you could do as many of these guys as you want. You need to get their name, and then once you get their name, you also need to make sure that when they move around, you're like recording their positions with the keyboard, and then sending that into the socket, this web socket that we're building. So once you have that web socket created, then like you need some sort of event for a key press, and then feed that key press into the server, and make sure that everything that like when a event is caught by the server, it shows up in all the other different spaces, right? And then lastly, there's a small animation that when you move around, you have like a slight jiggle of the box, right, just to show movement. And that's just a small thing. But we need all of those different features that we need to implement over here. So if you go to the GitHub that is sent in the Discord, let me just do that. You can see a branch for the complete code and then the main code. Over here, I have both cloned. The complete is complete, and then the main branch is just normal. So if you take a look over here, index, oh, sorry, this is for complete so far. Yeah, so if you look at index.html, which is in the public folder, this is like more or less empty. I just removed some of like the basic HTML stuff and then replaced it with this script statement. This is sort of just an import for the socket to make sure that it's included in the work that we do. And then if you look at index.js, this is just basic server. If I run this, it's just going to say server running on localhost 3000. You open that up and then you know that a server is running. So within this, we're going to basically have the server that's managing the socket. And then and then we're going to have in the index.html some sort of socket code that feeds into that WebSocket, and then make sure that as changes are happening, they're showing up in the front end. So once you have that, that's pretty much the entire project, right? Can I log into the GitHub here? Oh yeah, I did. Just so I can see. Okay, so I'm gonna work through index first. So that's this over here. So just looking through this, you have like all the imports. That's pretty basic stuff. And then the port, etc. And starting over here is where we start having actual code. So I'm gonna like sort of have some like game states, like game state variables. So the first one is going to be the variables, the players, right? So the players that are involved in the game so far. And then when a player connects, and we're just going to call that event connection, pretty basic name there. This is going to take in the socket that we're using as a parameter. And then this is going to sort of be the event on which a player enters. So then there's just some basic index.js. Yep, there's just some basic logic that we're going to do here with the color. I'm just going to copy paste this. This just picks a random color for the box to be. And then the next piece of logic that we have here is actually creating the player object. So I'm going to have a player, it's going to be a JSON. I mean, not a, sorry, a JavaScript object. And this ID is going to be the socket.id, which is just some unique identifier that works for identifying this player. And then this player is going to have an X position and a Y position. And that's just going to be another sort of randomly generated value, right? And then it's going to have a color, which we already determined, and then a name. And then we're going to have to figure out that name in just a second. But for now, we'll just leave that as blank. And then we're going to sort of use this player's map and then add that into there. So now we have this. Oops, this should be player. And then now this is basically the whole logic setup for when a new player joins, right? But we do actually have one more step here, and that's notifying that the front end that a new player has joined. And how socket does that is you run socket.emit, emit, and I'm gonna call this event init for like initializing a new player joining, and then enter in players. And this is basically going to tell the UI that a new player is joining. What should the player be seeing? They should be seeing all the players. So then you're going to pass in all the players, and that players is going to include the colors and the positions and then all of that. And then sort of like the opposite of emit, like instead of emitting to the object that called the socket, you want to also broadcast it to everyone. So there's another socket. This is the second most important socket like function, right? That's socket.broadcast.emit. And this is sort of the same exact thing, except instead of telling its own like local screen that a new player is being added, you want to tell everybody that a new player is being added. So the new player registers on everybody's screen. So then you're going to tell call this new event new player, and then pass in player, and then that's going to be the new player. Can be emit. Okay, so that's that. And then we're going to do the next event, which is when a player moves around. So I'm just going to call that socket.onMove, call that event move. And then I'm going to pass in the direction of the movement and create a function off of that. And then I'll just have a helper method called handle player movement and pass in direction. Yeah. Oh, and I'm also going to pass in the ID of this socket, just so you know like which player is moving, the one that's going to be moving on the screen. And I'm just going to copy this handle player movement function because it's fairly basic and it's just a lot of cases. What is this? Okay, and plug that here. Actually, yeah, I'm actually going to plug that outside of this socket.connect because that needs to be global for everyone. Okay, so now you have this. This handles all movement. It just says like calls this function handle player movement, gets the direction. If the direction is up, then you're going to change the X and Y values respectively. Nothing too complicated there. And then after that, you're going to have an emit that's sort of like a return call to a player object that says that the player is moving so that it knows that things are happening. But emit only emits it back to the own object. So we also need to make sure that everybody else knows this. So that would need a broadcast. But yeah, that would need a broadcast. So the next thing that we need to do is handle the name. The name over here is obviously left blank. Then that's because we need to deal with it here. So that's going to be another socket.on call, which is handling another event. I'm going to call that name given. And that's just going to be when somebody fills out that like prompt at the top that said, what is your name, right? That's the only time when this is going to be called because this is pretty basic. There's no way to edit your name in this game. So I'm just going to record the player ID. It's going to be sockets.id. And then updating this object to be the new name. And then sort of like another return call just to say that this is registering. So yep, that's just handling the name changing logic. And then I'm gonna have one last socket.on, and this is for when a player disconnects. You want to remove them from the player object. So another callback function here. And then this is just gonna delete players and socket.id. And with that, I'm just gonna copy paste this. Okay, and that's when a player disconnects. And I believe that should be this entire function. If that doesn't work, that's probably because I did a typo, but this is the actual code. And yeah, I believe we included everything. Just sort of reviewing that one last time, and I'll ask if people have any questions in just a sec. I have a connection, io.on connection. And this is basically taking in a socket, creating this player, and then I have a dot emit over here that tells everybody that a player is joining, as well as yourself that a player is joining, and then a on move, which handles movement, name given, which is when the name is entered, and then disconnect for when a player disconnects. So that should be all of that. Any questions on index.js? Maybe in chat. Nope. Okay. So we can move on to HTML now. A lot of this, I don't know if the boilerplate on the GitHub main branch has like all of this, but I just also cloned the like the completed GitHub and then copied like all of the sort of CSS and HTML type stuff because that's not the main focus. The main focus is gonna go inside the script block. And that's going to be sort of handling the other side of the socket. So the side of the socket that's registering the movements of all the other players and all of that. So if we take a look over here. Yeah. So if we take a look over here inside this, I'm going to do const socket equals IO there. And const player elements is going to be this. So this player elements is just going to store that like X, Y, name, etc. Type stuff. And if you remember back to the index.js file, we said that there's going to be an emit of init when a new player is joining. That's going to sort of initialize the player with all the necessary values. So I'm going to do socket.on init, then all the players, and then a function there. And then this is going to prompt for their name. Oops. Oh, did I forget like an extra parentheses or something? The arrow. Oh, my bad. Okay, that should be good. Yeah. So const person, you get the username. And then for each of the player IDs and players, I'm gonna sort of add that to the players, the player elements. And then I'm gonna have another helper function called create player element for this player. And I'll copy paste this as well. Because it's a lot of like HTML type stuff. So put that down there. This is basically just like adding the name to the player like below them. And then like yeah, and then adding the position to the of the player using like the CSS styling. So like get the X, add pixels tag onto there, and then returning that player. And then that player is created in this player elements. Okay, so now once you have that, the next one that I'm going to create here, another socket.on, is going to be the new player, right? So that's going to be when a new player joins. That's not myself. And then I'm going to create that new player like this. So pretty basic, just one line inside that. That's just when somebody new joins. And that's because we already handled all the new logic for creating a new player. And that's all over here anyway, right? So basically for each one of these emits, we need to make sure that something is catching that emit inside our HTML and then processing that on the front end. And I believe there's two more. Yeah, two more. This one is a bit long, so I might copy some parts over just because it gets annoying. So when a player moves, you want to get the player that's moving. And that's going to be from the player elements map. Oh yeah, this is more CSS styling, so I'm just gonna add that. So, oh sorry, here. So over here on player moved, let's copy that. And just to review that, that's just gonna get the player and then get the new X and Y values and then change the styling so that the new player is in the right place. And then rotate it sort of like a small animation so it looks cool. That's about it. So that's the player moved. And if I run this now, I think it should mostly work. It might actually throw an error because I'm not catching some of the socket emissions. But this should be like the basic logic of the game. I just want to add some small things that are for like sending out a disconnection and then also name send. Honestly, this isn't super important. It's just making sure that the name is updated. So I'll just like copy this over as well. Yeah, so when a name is sent, you just want to update that name. Make sure that that's like the name tag is added below. And then lastly, player disconnect. When a player is disconnected, this sends out an image that a player is disconnected. So then you want to remove that from the player element list so that they're not registering on the board anymore. So then that's for player disconnect. And I think there's only one more now, so almost there. We just want something that catches when people are like when the keys are being pressed. So that's gonna in HTML, that's like an event listener. The event is called a key down. And then you take in E and then get the direction. Yeah, and you're just gonna do this for every type of direction. Down, left, and right. And then you want to send that back to the socket server that it knows that something happened. So if that's not a null value, then you want to socket.emit move and direction. So then that's going to be move. Where did I handle that? Yeah, here. So socket.onMove. There's a handle player movement. So this is going to be the emit that's sending that to the socket. So that's the player movement. And then now I think everything is done. So unless I typoed something, this should work. Fingers crossed. Uh-oh, my box is gone. Maybe because I'm zoomed in. Let me try again.
Here's the type of thing
In HTML.
yeah. In the for loop that's going through players to players.
Oh. Um, oh shoot, I need to get that right. Sorry, give me a sec. I think my laptop powered off. That's weird because I started at like 60%. But I probably typoed something else. Okay, that's because I have a bunch of these. But as you close them, you can see that they disconnect. So now you have the movement animation. And if I join in a new localhost, yeah, if I join in a new localhost, you can see that they're moving around together. And you can see all the ones that are on this other Chrome tab that I should have probably deleted their tabs, but if I did, you would see them disappear one by one, like this one, right? But yeah, other than that, I believe that's everything. Any questions on anything from the demo? Hopefully, other than like the typos, like all the logic made sense. Anything from Zoom? Nope. Okay.
Real good.
Yeah.
Yeah, close that.
We could just go back to the sign in form 92.
Right.
We're already good.
Okay.